Assalamualaikum and selamat sejahtera. Now, we will apply the same principle on the operation of full wave rectifier with resistive load. Based on the graph, the control signal is applied at alpha equal to 0. Furthermore, since the rectifier can conduct current in both positive and negative half cycles of the supply voltage, thus, we need to apply the control signal for every half cycle or 180 degrees. In this condition, the rectifier is supplying maximum power to the load. As you can see, all voltage and current waveforms are similar to the voltage and current waveforms of uncontrolled rectifier with resistive load. Next, I will shift the control signals to the right. Due to the new firing angles, the conduction range of each thyristor reduces. As discussed earlier, all voltage and current waveforms except the supply voltage will be chopped before the control signals. For the full wave rectifier, it happens at the starting of both positive and negative half cycles of the supply voltage waveform. I will show the transformation starting from the top waveform to the bottom. Based on the graph, I tabulate the conduction range and the conduction angle of each thyristor in this table. For waveform analysis, we will focus on the average and RMS output voltages, ripple factor, and rectification ratio of the rectifiers. As usual, I will start with the waveforms and equations of a single-phase uncontrolled half-wave rectifier with resistive load. Now, I will change the waveforms based on the operation of a controlled rectifier. Based on the new output voltage waveform, the voltage equations will change as follows. As we can see, the integral range has changed the starting angle from 0 to alpha. Next, let's compare these voltage equations to the voltage equation of uncontrolled rectifier. From both equations, we can see that the firing angle has caused the average and RMS output voltages of the control rectifiers lower than the uncontrolled rectifier. Lastly, I will compare the ripple factor and the rectification ratio of both rectifiers. The left side is referring to the control rectifier, while the right side is referring to the uncontrolled rectifier. By considering Vm equal to 1 volt and alpha equal to 30 degrees, we can see that the control rectifier has lower performance than the uncontrolled rectifier due to the firing angle. Based on this information, we can conclude that the firing angle is inversely proportional to the average and RMS output voltages and also the performance of control rectifiers. Lastly, I will show the differences in terms of waveforms and equations between uncontrolled full wave rectifier with controlled full wave rectifier supplying resistive load.